any straws.
For the water.
For water, yeah, because we're gonna make water.
Should we back up even more?
Sure.
He's just not gonna let us know.
Yeah.
Can we or should we?
What?
Thank you for staying in the room. I appreciate that. So, should I put on safety goggles?
Yeah, that's probably a good idea.
Got my safety goggles, right? Safety first. Make
Safety
an example.
first.
Alright, so either this is just going to be a balloon popping, or it's going to be a little more than that. You guys ready?
Yeah.
He's plugging his ear. Whoa, I saw
Yeah, more than that.
That was hard. That was definitely. So the yellow one. The yellow one was hydrogen. What did you guys see?
fire.
Fire. You saw a big fireball. What else? What else did you notice?
I heard it.
You kind of heard it, right? You can kind of hear it. You saw a fireball. You can kind of see it for a little bit of time, and you saw that big flame, right?
That was
I kind of felt
Kinda
the
go
pressure
out.
wave.
You can kind of feel.
Yeah,
You kind of feel a pressure wave.
True.
This guy probably is helium. So what do you guys expect to happen with this?
Yeah, just a little pop.
Probably not a lot, right? Well, I will still just be cautious in case it's hydrogen and oxygen. You never know. You guys ready for this one?
Yeah.
Does that look like helium?
Yeah.
Helium. Nothing really happened, right? All I did was pop the balloon there. So definitely the green, green one.
Yeah.
The green one was the helium one.
Do we save the best for last?
Well, we'll see. So here's what I'll ask you:
You started with hydrogen and oxygen.
Why? What's the big difference in terms of this balloon and this balloon?
Concentration.
The oxygen, the concentration, right? In order for these things to interact, we have to bring hydrogen to oxygen or oxygen to hydrogen.
The oxygen helps it burn more quickly.
Yeah. So in the oxygen or in the hydrogen balloon, right? We had to wait for oxygen in the atmosphere to get to the various hydrogen molecules, right? So there were a bunch in the middle that weren't near oxygen, so they couldn't burn immediately. Which is why you saw that kind of flame, it kind of flamed out as the hydrogen was able to get to more oxygen in the atmosphere.
Blue is red.
Here, do we have that problem?
No.
No, we don't. We mix them together, right? We mix them. So now it's super easy for my hydrogen to find an oxygen everywhere, right? So they're just all very, very close. So do you expect a faster reaction or a slower reaction? Faster, right? So it's going to be much more quick. And that's just because we have a higher concentration.
Is your yellow balloon the
Green
wet
we
one
go.
inside?
Is the
Pardon?
Yellow,
Is your yellow
slow
balloon
down.
wet inside since it had water?
So that's a good question. Can you repeat your question?
Just if the yellow one's wet on the inside, if it's creating water.
So aside from a
You mean
scorch
the
mark,
green
no.
one?
No.
Yeah, so it created water, but why do you think we don't see that it's wet?
The one you see.
Heat evaporated.
Because it's hot. Yeah, because it's so hot, it's just gaseous. So it's just gaseous. Oh wait, let me. I don't want to hold the fire and this while I'm carrying. So that one should be the one that has both hydrogen and oxygen in it. So we're expecting a quicker reaction, right? We're going to release all that energy at once.
Yeah, probably.
So do you think it's going to be louder or quieter?
Yeah, louder.
And do you think we're going to see as big a fireball or a smaller fireball?
Smaller.
I mean, bigger.
Gonna go very fast here.
Just gonna go faster.
So let's see, you guys ready?
Yeah.
That's why the other teacher went.
Yellow, green, blue.
Awesome.
So,
Like that.
what did you guys see? Yeah. What did you guys see?
I made it red. It's gonna have blue.
I didn't see anything, I was forced.
Oh, is that red?
He wrote blue there.
Red. So, was that louder or quieter?
Wow. No wonder you want to send an email
Was
out.
that fireball, was that fireball a shorter duration or did it last longer?
Really
It was
bright.
quicker, right? It was a really quick fire. Quick bursts. Right? So this was a much quicker reaction. Last time we saw that fireball kind of Because, again, the hydrogen had to get to the oxygen, That's like when when you light a match, just FYI, when you light a match, the idea here is that you'll notice the flame is up here, right? And the idea is that the heat from this fire is vaporizing some of the material, so now it's able to get to the oxygen that's surrounding it. So you're able to get to the oxygen that's surrounding it. Because in the middle of this flame, right, there's no oxygen at all. So that's why we see sometimes those cones, if I get this right, when you have a really hot flame, you can kind of see a cone on the inside where there's not as much oxygen. That's why these have these sort of characteristic shapes of trying to get to the air that's around them. And that's why, like in your car, you have like fuel injection systems. You mix the air with the fuel before you try to combust it. You want to mix the fuel with oxygen before you try to burn it, so you get a faster, more forceful reaction. Is the idea. Just as a side note, did anybody feel it?
Yeah.
You can feel that, right? You can feel that. Why did we feel it?
Pressure.
There's a pressure, right? So as that hydrogen and oxygen got really hot, what happened to the gas? Did it contract or expand? It expanded, right? It just expanded real quick, so then that sent a little shock wave, a little, concussive force. So you could feel that shock wave go through you as it hit. So here's just an example of kinetics.
How come
Right.
there's little particles floating around the air?
That could
balloon.
That could be water, that could be balloon, that could be smoke from this.
Oh.
It
shouldn't be
stars from
burned
space.
up most things too, didn't it?
Yeah, I should burn some balloon. So any questions?